Our next unit is Unit 6. So as we start in with Unit 6, it's exponents. We're going to do a lot of number crunching right now. So up until now, last couple chapters or units have really been more about linear equations and understanding and writing equations, interpreting, etc. Right now, we're going to kind of take a step back and we're going to do some number crunching. We're going to do some skill building with some exponents. So as we start in with some skill building here, we're going to do a quick little review, and then I'm going to give you some input on some other things we can do with exponents. Okay, so first of all, we're going to start in with adding and subtracting monomials. We're going to simplify expressions with adding and subtracting, basically like terms. So starting off, if I have 17x, take away 25x. Hopefully you guys know that that just means I'm going to take 17 minus 25, and my descriptor is the x. So it would be a negative 8x. Just combining like terms. Now with that being said, if my like terms are y squareds, they're still alike and I'm still adding them. If I have an order for 23 y squareds and I have 6 y squareds in stock per se, it's still going to be negative 23 y squareds plus 6 y squareds. Negative 23 plus 6 is negative 17, and the object is y squared. The next one I have 38 x squared y minus x squared y. Well, my terms here are still x squared y's. And there's not a number in front of this, but we assume it's a 1, so it's negative 1. So 38 minus 1 is 37, and my descriptor is x squared y. On D, I'm looking for like terms, remember that. So I've got an AB here and an AC here. The A is similar, yes, but the B and the C are different. So the AB and AC are not the same. It's kind of like having two kids with the same first name but different last names in class. They're not the same person, okay? So I might have items that have their name on them, but it might be Jason Smith and Jason Jones. Well, if I have a Jason Smith and Jason Smith, they're itemized here. There's 2 of those things, and I say his name on them. Whereas over on this other one, I have 9 items that were left behind that were Jason Jones's. They're not, I can't just give them to the same person. So this is done. They're already in simplified stacks, as is. The next one, I have 3y plus 9x plus 4y minus 3x. Well, combining like terms back like this very first one that we had. I'm going to underline, go alphabetical. So I'm going to underline my x's and I'm going to box my y's. Remember, the sign in front of a number goes with it. So x's, I have 9x minus 3x, which gives me 6x. And over here I have 3y plus 4y, and that gives me 7y. I'm going to add those because it's a positive. The next 4, I'm going to actually have you write them out and then simplify them, just to work with our signs just a little bit. So I want the sum, means I'm going to add them. So if I add 16y squared plus negative 5y squared, plus that negative right here means it's a minus, remember that? So now I'm going to say 16y squared and take away 5y squared. Gives me 11y squared. Find the difference means subtract, 10x squared y and 2x squared y. Well, 10x squared y minus 2x squared y's. They are x squared y's, x squared y. So 10 of them, take away 2 of them is 8 of them, x squared y. Find the sum, means I'm going to add, and it's going to be negative 24y squared plus the negative 2y squared. And again, I'm adding a negative, which means I'm actually subtracting. So negative 24y squared minus that 2y squared. Again, there are still y squareds, so they're the same item. And negative 24 and negative 2 of them gives me negative 26y squareds. find the difference. So it's difference to subtract. So I've got 9a minus the negative 15a. Negative negative makes a positive, so it's going to be 9a plus 15a. And that gives me 24a. So that's a review. This was all review, combining like terms, watching your signs, writing sums and differences. Now we're going to get into exponents, a quick little review of exponents, or actually an intro to exponents. So as I'm introing exponents, I'm going to try to explain what they mean along with it so that we can actually have it conceptually. 2 squared really means I've got a square that is a 2 by 2. So if it's 2 this way and 2 this way, I end up with, if I counted the little squares in there, I would have 4 1 by 1 squares. So 2 squared really means 2 times 2, because to find area you would multiply length times width. So 2 times 2 is 4. Not because I'm multiplying the 2 by its exponent of 2, but I'm actually getting 2 of the base, 2 times 2. This means 0 of the base. Now there's a rule there. The rule for that is any value to the 0 power equals 1. So that is important. Equals, I'm going to put a big 1 there. So that value is 1. I'm going to skip the next one real quick because we're going to come over here to 2 to the third. 2 to the third means I'm going to have 2 times 2 times 2, because I want 3 of that base. So 2 times 2 here is 4, times 2 is 8. This is 3 squared, so if I have a square, my 3 squared, that means I would actually have a box that's 3 by 3. And I would actually have 9 little squares, so because it's 3 times 3. Same thing with 5 squared would be 5 times 5, which gives me 25. Once I get more than that, like here's 4 to the 5th power, I'm really saying that it's 4 times 4 times 4 times 4 times 4. So if I multiply that out piece by piece, that gives me 16 times 4, which is 64, times 4, which is 256, times 4. And that's when I end up getting, I believe it's 1,024. But when you get to this kind of a problem on your calculator, I'm going to kind of show you on your calculator, there's a caret button. There might be like a Y to the X button or an X to the Y button. You might have a button that is Y to the and have a box, or an X with a box. I think those are your main ones. If you need to see me about your calculator, show it to me and I'll see if I can figure it out for you. So then what I've got 6 to the 3rd power means 6 times 6 times 6, which is 36 times 6, which gives me 216. Now this one over here is 7. This is actually, there's no exponent here, so it's understood that it's a 1. So it's actually 7 to the 1st power, or just 7. 1, 7. 3 cubed is going to be 3 times 3 times 3, which means it's 9 times 3, which is 27. Now, if you noticed, I saved a few of these, 2 of them actually, with the negative exponents on them. So I'm going to go over those with you now. So if I have a negative exponent, okay, right now it's actually a fraction that's like this. It means it's out of place. So it really needs to be moved to the bottom. So it's I'm going to go down to the bottom. It's going to be 1 over. Then it becomes 2 squared, which is 1/4. Same thing over here. This is going to make it a fraction. So I'm going to move it to the bottom. So it's going to be 1 over 5 squared, which ends up being 1 over 25. Now to explain that reasoning, as I go through this, I'm going to actually use the power of 10. So if I go with a 10, 100, 1,000, and then I go with a 1, and then I'm going to go a 1/10 and a 1/100th. Okay. let's think about these as what their value is. Well, 10 is 10 to the first power, correct? Because 110. 100 is actually 10 to the second power because it means 10 times 10. 1000 is 10 to the third power because it's 10 times 10 times 10. 1 is 10 to the 0 power because we know anything to the 0 power is 1, right? So it's just 1. Now 1/10 is actually 10 to the negative 1 power. So it's a 1 over 1 to the 10, or 10 to the first power, which is 1 over 10. So 1/100th is actually going to be 10 to the negative 2 power, because it's 10 to the second, which is 100, but it's 1 over 100, so it's negative 2 power. We'll get more into that a little bit later on. Overall, let's see what we have here on our what do you notice. Now, hopefully you notice a few things. Hopefully you notice that a negative exponent makes a fraction or rational. And you hopefully also remember that any value to the 0 power equals 1. So what number without an exponent shown indicate? Well, if it doesn't have an exponent, it means the base has a power of 1. All right, so I think we're ready to get into our actual work here. We do have some boom cards for you. I want you to start in on those on your, like we did them in class on whiteboards, but make sure that you understand how to do them. This is a great little warm-up. The link is here. It is also in OneNote and in Summit. So parts of a monomial. We're going to start with parts of a monomial. I have the coefficient is the number out front of a variable. So in this case, it's the 3. The base is the value raised to a power. So in this case, it's the x, because x is being raised to 4. An exponent is the superscript value. Should I put a different color in there? Superscript. And that is going to be the 4. So what is the area of a square with each side being 5 feet? Well, if I have a square, we're going to say that this is a square because I'm going to put in my little tick marks, which means they are all the same. So if they're each 5 on their feet, and so S basically, where S is the side of the square. So area is equal to side square, where S is the side of the square. Well, the side of the square is 5, so this means that S equals 5. So algebraically, I'm going to say that A is equal to 5 squared, which is equal to 25. So area here is equal to 25, and in this case, it's feet. So it's going to be feet squared, because if I were to make this into marks, I would end up with 25 1 by 1 foot squares. Okay. At this point, we have done a little bit of, we've done 0 product, or excuse me, the 0 exponent. And we know that the 0 exponent means any value to the 0 power is 1. Equals 1, right? Now we're going to get into the product rule, which is the first one. So we're going to actually work on this one, where I say that the x, or the a to the x and a to the y is equal to the a value to the x plus y. So my base stays the same, but I add those exponents. And that's what I say here. Keep the base the same and then add those exponents. So I call it a little jingle kind of in my head. Same down low, add and go. So I'm going to add those exponents. Keep the base, so I've got x, and add those exponents. M plus n. So multiply the coefficients and then use the product rule for the variables and exponents. So this first one, I've got x squared and x cubed. Well, really what this means, I'm going to show you what it means. It means x times x, and this means x, x, and x. But if they're all being multiplied, I actually have 1, 2, 3, 4, 5 of them. So it's x to the 5th power. My rule says that it's x to the 2nd plus 3. Because same base, keep the base, and add those exponents. And 2 plus 3 is 5. So the next one, this is like a power of 1. So this is going to be a to the 9 plus 1, which gives me a to the 10th. And you can always pause me, try them on your own, and then check with me. So this next one, I'm going to multiply the coefficients. So 4 and 3 is 12. And then I have x to the 2nd and x to the 5th. So I'm going to keep the base, and I'm going to add those exponents, 2 plus 5. That gives me 12, x to the 7th power. All right, so D is very similar to the one we just did. So try it real quick and then come back to me. And if you feel confident, you can go on to E as well. So I end up with 3 times 5 is 15. X, and I'll get to the 6th and to the 2nd. So 6 plus 2. So I get 15 x to the 8th power. On E, I have 8 and negative 3. Again, there's no powers outside, so I'm just working on the inside here. So 8 times negative 3 is negative 24. I have x to the 4th and x to the 4th. So it's going to be x to the 4 plus 4. And y, I've got to the 2 and to the 9, so 2 plus 9. And that gives me negative 24, x to the 8th, y to the 11th. Letter F. Again, this one has a coefficient of 1 because it's not shown, so it's just a 1. So 6 times 7 times 1. Well, 6 times 7 is 42, times 1 is 42. Now think about my exponents. I know that there's not one shown, so it's a 1, and there's not one shown, so it's a 1. So now I can add those exponents. So I end up with m. I've got a 1 plus 2, and there are no more m's. N's, I have a 1 plus 4. So I get 42, m to the 3rd, n to the 5th. On G, okay, now G, I'm doing the same thing, except for I didn't put parentheses around them, but it still has a dot, which still means multiplication. Okay, so they're still in a row, they're still multiplying. Here are my coefficients, the 8 and the 10. So 8 times 10 is 80. Now start with our variables. I've got C, and it's going to be 9 and 3, so 9 plus 3. And D is going to be, this is a 1, because it's not shown, so it's a 1 and a 5, so 1 plus 5. So 80, C to the 12th, D to the 6th. So all of these were working with that product rule. Now we're going to go down and I'm going to combine the two. We're going to put it together. So putting it all together. So far. So I'm going to look at this. I'm still going to use order of operations, PEMDAS, right? So I'm going to parentheses, there's nothing to do on the inside. Exponents, there's no exponents on the outside. And I'm going to multiply and then divide, which there's no division, and then add and subtract, which I do have addition. Right? Another way to write this is this way. And I like to write it this way because, just a quick note, when I multiply exponents, right, so it's parentheses exponents. When I'm multiplying exponents, I'm going to add them. When I'm multiplying bases, I'm going to add. When I'm dividing, I actually subtract. You can kind of see this little chart. So multiplying is going to be adding. So adding those exponents. So here we go. And box my multiplication because I want to do those first, and then I'll do the addition. So 2 times 4 is 8. And I've got x to the 5 plus 1, because that's a 1, and a y to the 2 plus 3. So this gives me 8x to the 6th, y to the 5th. And then plus. Over here, I have, this is a 1, so 3 times 1 is 3. X to the 4 plus 2, and y to the 4 plus 1. So I get 3, x to the 6th, y to the 5th. So at this point, I did the product rule. And now I'm going to combine like terms. So I'm going to validate that this term and this term are the same. And if they are the same, then I can add them. So I end up with 8 of them plus 3 of them gives me 11 x to the 6th, y to the 5th. And then we have letter I. We're going to do pretty much the same way. We're going to box this front part, so it's multiplication. We're going to box the back part, that's multiplication, and then we'll add them together. So I'm going to circle it so I don't lose that. All right, so I've got 4 times 5 is 20. I end up with an a to the 3 plus 1, because this is the power of 1, and b to the 4 plus 2. So I end up with 20, a to the 4th, b to the 6th. Then I'm going to do the other side. This is like a 1 out front, so negative 2 times 1 is negative 2. I have an a to the 2 and 2, so 2 plus 2, and b to the 5 and 1 to the 5 plus 1. A to the 4th, b to the 6th. Now I still need to use the rules of mathematics. So a positive and negative right next to each other is minus, so it's going to be a minus. So I've got 20, a to the 4th, b to the 6th, minus 2a to the 4th, b to the 6th. Validate that I have the same terms, like terms, and I end up with 20 of them, take away 2 of them gives me 18, a to the 4th, b to the 6th. Same thing on the bottom too, I do have subtraction there. So let's kind of make sure that we don't lose that subtraction piece. This first part is completely done over here. So we're just going to have to like work with that part. So I'm going to have 19 m to the 8 n to the 8 minus, and let's go ahead and simplify this part. I'm going to put it in green so we can kind of see it. 4 times 3 is 12. I've got 5 and 3, so 5 plus 3. And n is 1 plus 7. So I have 12 m to the 8, n to the 8. And here I'm 19 m to the 8, n to the 8. Validate that they are like terms. And 19 of them take away 12 of them gives me 7 m to the 8, n to the 8. And the last one, before we go to the quizzes in Google Classroom, I'm going to box this first part, box the second part, so we have to multiply those out first, and then we're going to subtract. I've got negative times a negative is a positive, so it's 15. X is going to be 1 plus 4, and y is going to be a 1 plus 1. So 15, x to the 5, y to the 2, minus. Over on this side, I've got 7 times 2 is 14. I've got x squared, x cubed, so x to the 2 plus 3. And I just have a y squared. So 14, x to the 5th, y squared. I'm going to validate that I have like terms, x to the 5th, y to the 2nd. And I've got 15 of them, take away 14 of them gives me 1, x to the 5th, y to the 2nd. In Google Classroom, you have a multiplying monomials practice. It is listed as an 8.1. That goes with the actual textbook that Park Hill and Park Hill South use. It's a district adopted material. So it does, I have made this to also fit with the book. So it is multiplying monomials. Once you've done that, request feedback, and that'll be requesting feedback on checkpoint 2. I'd appreciate it if you would snip and clip that and put it in there. This is checkpoint number 2. And the notes today are checkpoint number 1.